So what we had discussed previously were the quadrantal angles. This angle is 0 degrees. This is 90 degrees. This is 180 degrees and 270 degrees. At each of these values, we can also represent them with radians. So this is 0 degrees, or we can also say 360 degrees, or 2 pi radians. So at 90 degrees, that is pi over 2 radians. 180 degrees is pi radians, and 270 is 3 pi over 2 radians. At each of these values, we can also represent them as points. Remember, this is a unit circle, so if we move 1 in this direction, that our ordered pair would be 1, 0. Similarly, if we move 1 in this direction, our ordered pair would be 0, 1. If we apply the same reasoning here, we can move 1 in this direction, and the ordered pair would be -1, 0. Moving 1 down would put us at 0, -1. In order for us to have a better understanding of sine, cosine, and tangent, we could remember something from geometry. Maybe we remember this acronym SOHCAHTOA, where S represents the sine function, C represents the cosine function, and T represents the tangent function. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And it's always with respect to a particular reference angle. So suppose that we choose a reference angle theta. A theta could be anywhere, but it could be either here or here. All right, we know it's a right triangle, so this angle has to be 90 degrees. So this is where we have theta. So theta has an opposite side, and it also has an adjacent side. If we move the location of theta, let's say that theta were here instead. Now, this is the opposite side, and this is the adjacent side. So adjacent just means close. So this side is close to our angle. So let's go back again. So we know SOHCAHTOA. So if we have an angle theta, and suppose that theta is in a triangle that has 3 and 4 as the legs and 5 as the hypotenuse. So what would the sine of theta be? Remember that sine is opposite over hypotenuse. In this case, our opposite is 4, and our hypotenuse is 5. So sine of theta would be 4 over 5. What about cosine? What do you think it is? Cosine of theta is going to be adjacent over hypotenuse. So adjacent would be 3 in this case, and hypotenuse is 5. And if we use the same reasoning, the tangent of that angle would have to be the opposite, which is 4, over the adjacent, which is 3. To continue building information about the unit circle, we want to remember our special right triangle, which is 30, 60, 90. So we know this is 90. Suppose that we put 30 here, 30 degrees, and 60 degrees here. So 30 is going to have an opposite side, according to what we remember from geometry. It's going to have an opposite side of 1. 60 is going to have an opposite side of radical 3, and the hypotenuse is going to be 2. So let's figure out some functions here. So some values. So sine of 30 is opposite over hypotenuse, So opposite of 30 is 1, and the hypotenuse is 2, so it's 1 over 2. Cosine of 30 is adjacent over hypotenuse. So here's the adjacent. So adjacent would be radical 3, and that's going to be over 2. So if we follow the same reasoning, then that means that sine of 60, opposite 60 is radical 3, and hypotenuse is 2. Cosine of 60 is 1/2 by the same reasoning. So remember these values, we're going to use them later. Or make sure you have them written down. Another right triangle we'll have is our 45, 45, 90 triangle. On this one, if this side is 1, then the other side is 1 as well. We're using Pythagorean theorem, this side has to be radical 2. So if we want to find the sine or cosine, so sine of 45 is 1 over radical 2. And the cosine of 45 is 1 over radical 2 as well. So remember, sine is opposite over hypotenuse, and cosine is adjacent. Remember, we're using this for our reference angle. So it'll be adjacent over hypotenuse. But 1 over radical 2, we can rationalize it. In other words, we can get rid of the square root in the denominator. So we can multiply by radical 2 over radical 2. This is going to give us radical 2 over radical 4. Of course, the square root of 4 is 2. So really, we're saying that 1 over radical 2 has the same value as radical 2 over 2. Again, write these values down. We're going to use them later. So let's think about what sine and cosine would look like on the unit circle. Remember, when we talk about a unit circle, unit refers to 1. So what we're saying here is that our radius is 1. So suppose we have a point on the circle, some coordinate x and y, and we drew a line out to it that this line would be the radius and would have a value of 1. So think about how we would get to this point xy. So the x value tells us that we'd start at the origin and we go x amount of spaces along the x-axis. The y value tells us that we would have to go y amount of values, or the value of y spaces along the y-axis, or up in this case. So let's say that we drew this triangle. Actually, we know what the values of this right triangle we just drew are. That this leg would have a value of x since we went x spaces, and this leg would have a value of y since we went y spaces. So let's say we drew that triangle here. And we fill in the values. So 1, y, and x. And let's say we say this is theta right here. So sine of theta is going to equal opposite over hypotenuse. So it'll be y over 1, which is just y. Cosine of theta is adjacent over hypotenuse, which is going to be x over 1, or just x. So basically, what that tells us is that x is the same as cosine of that same angle theta, and y represents the sine of that same angle theta. So again, this is important for us to remember later on. This relationship is always going to happen on the unit circle. X is cosine and y is sine of our reference angle. So suppose that we wanted to represent what we found for 30 degrees on the unit circle. First of all, 30 degrees is the same as pi over 6 radians. We know also that the sine of 30 degrees is equal to 1/2, and that the cosine of 30 degrees is equal to radical 3 over 2. So let's say that we put all this information together, and of course we say that the point xy associated with that the x represents the cosine and the y represents the sine of the reference angle. So if this angle here represents 30 degrees, then the point here would have to have the cosine of 30 first. So the cosine of 30 is radical 3 over 2. And the sine of 30, that's going to go next, that's 1/2. So we can fill in the rest of the values. Of course, this happens at 30 degrees or pi over 6 radians. We know that at 45 degrees, we said that sine of 45 degrees was radical 2 over 2, and that cosine of 45 degrees was equal to radical 2 over 2. So the point associated, let's say that we say that this is 45 degrees, that means the point associated with that, the cosine goes first. Cosine is radical 2 over 2. The sine is next, it's radical 2 over 2. We know that it's 45 degrees, which you can pause it and try and see if you can figure out what 45 degrees is in radians. So that would be pi over 4 radians. For 60 degrees, let's say that our reference angle here is 60 degrees. We want to find out what this point is. Remember that for sine of 60, that sine of 60 is radical 3 over 2. And that the cosine of 60 is 1 over 2. So if we did our point here, remember cosine goes first, it would be 1/2 comma radical 3 over 2. This value occurs at 60 degrees, which, what would be the radians for 60 degrees? It would be pi over 3, so pi over 3 radians. So let's put together what we know about our unit circle. We know this point here is 1, 0, that the first value is, that this occurs at 0 degrees, which is also 0 radians, or 360 degrees, and also 2 pi radians. The next point here would be 30 degrees, and at 30 degrees, the point is radical 3 over 2 and 1/2. This is, of course, 30 degrees or pi over 6 radians. The next point here is at 45 degrees. 45 degrees, went for that particular reference angle, we had radical 2 over 2 and radical 2 over 2. Again, the angle was 45 degrees, which we found out was pi over 4. For this particular angle here, we know that it was 60 degrees. At 60 degrees, we had 1/2 comma radical 3 over 2 for the point, and it was 60 degrees, and we had pi over 3 radians as being equivalent to that. Then we had our quadrantal angle here at 90. So that was 0, 1, and that was 90 degrees or pi over 2 radians. This point here was -1, 0 or pi radians, or 180 degrees. This point here is 0, -1, which is 3 pi over 2 in terms of radians, or 270 degrees. So this is what we found out, but how could we use this? How is this useful? Well, suppose that we want to find out how to plot a particular function, let's say the sine function. So suppose we wanted to find out what sine of 0 degrees is. Well, we know that 0 degrees happens here. And we know that sine is the second value in our ordered pair. So sine of 0 is 0. Or if we want to find, let's say, the sine of a larger value, let's say the sine of 45 degrees, or pi over 4. So the sine of pi over 4 is going to be found here, because all of this information here is for pi over 4. We know that the sine is the second value, so it's going to be radical 2 over 2. And we can keep going in this way. So if we want to find, for example, the sine of 3 pi over 2, 3 pi over 2, its information is here. The sine is the second value, so the sine of 3 pi over 2 is going to be -1.